Oh, nice. So, are you running your own virtual machine or something? All right. All right. Are you not able to log in here? You don't see your account here in the CloudX Lab? Or you just, it works, but you wanted to try your own? All right. All right. So today we will start with basically the machine learning, sorry, Spark R, and how do we do various things using Spark R. All right. All right. So there are many things to talk about today. We will talk about Spark R, we'll talk about Mahat, and we will talk about the ML lib and also one example of GraphX. Those who have attended the Spark course, they must be knowing already the GraphX and the MLlib use cases. All right, I will not be going detailed into machine learning, but I'll be telling you the example use case and how do we solve those use case. Okay, all right. So the great thing about R was we were able to visualize and analyze data almost immediately. Okay. The problem with R was that if the data grows beyond a certain size, you cannot use normal R because it would not fit into the memory. Okay, so and in case you go to a higher memory, but in case you go into higher memory, then the CPU will become the bottleneck because if you try to solve any machine learning problem, they require many iterations over the data and the complexity grows as the size grows in those problems, and therefore we won't be able to utilize the we won't be able to use R in those cases. Okay, so either the RAM or the CPU will become the bottleneck if the data grows beyond a certain size using the normal R. The various other R's, such as there is something called distributed R. It's an open source product. So some people are trying to make R as distributed. Okay, but the product is in a very nascent stages. It's not in a good shape right now. Okay, and there is another way of running R in a distributed fashion is by the way of MapReduce. Again, if the whole logic is to be broken down into MapReduce, then the whole purpose of data frame and those examples goes away. Okay, if you're just streaming input data through the R, then R is not being used as a algorithm language as a library, but we are just using R for cleaning up the input data, and that's quite clumsy. So that's where the Spark R comes into play. Okay, Spark R just released around 2 months ago by Databricks guys. So Spark R just have been out of the oven and it's doing really well. Okay, so most of the programs in today's world, when we want to analyze data, either either they come in the drag and drop format, like the one which we showed yesterday about the BIRT, where we could create the data set and drag and drop, or the other kind of tools. And in the same category of tools, you have Microsoft Excel or Google spreadsheet for the smaller set of data. Now, as the data grows, you can't use Microsoft Excel and you might have to use the BI. And if the complexity grows, then you might have to use R. Okay, what kind of complexity are we talking about? Let's say we are trying to do a linear regression. What does it mean by linear regression? Given given a whole lot of data of say two three variables x, y, and z, and we know that for these values of x and y, this is the value of z. Find out the value of z for the data points which are not part of the old data. Try to basically interpolate or extrapolate to basically guess the value of z, guess the value of z given x and y. Okay, and how? By by creating a linear regression model on top of the data. So these kind of problems are very difficult to solve using Microsoft Excel or similar tool, or even using SQL. All right, and that's where the tools like Spark R comes into play. Okay, all right, so that's how R comes into play. And when the data keeps on growing big, then Spark R comes into play. All right, so at the end of day, so we had talked about Spark and we talked about R. R has data frame and Spark has something called RDD. So Spark R is nothing but Spark R is nothing but a kind of a compiler for Spark R. It's kind of a compiler for R, which basically translate all of the logic of R into the actions and transformations in Spark. Okay, so and to do that, the whole library is being rewritten. Some of the functions, important functions, have been already written and others are coming up. Okay, so Spark R is not yet complete. It is basically a good enough model, working model of how we can distribute R. So this is probably the best way to distribute R. Make it distributed means even if you have few terabyte of data, you can create data frame out of it. Okay, you can load that data into data frame and then analyze it using Spark. Okay, so everybody with me with this Spark uh, pitch. All right, so it provides a lightweight front end to use Apache Spark from R. The way we used the way we can use Spark via Java, we can use Spark via Scala. The, in the same way, we can use Spark with R. Okay, and the beauty of the R is it comes up with a good set of functions which was already there in R. Okay, and also it has started supporting the older libraries, and which means the whole big library of R, which has been contributed by thousands of people, would be now available in a distributed fashion. We will be able to churn petabytes of data very easily using Spark R. All right. So Spark R provides a distributed data frame implementation under the hood, which is nothing but an RDD. Okay. So it provides you those operations which R also provides, like selection, filtering, aggregation, etc., similar to R, but on larger data set. Okay. And the machine learning part, it tries to get it done through the MLlib. Since there was MLlib, so MLlib already started providing good enough machine learning. So those functions of older R, which are related to machine learning, that internally when it get called is basically calling MLlib library instead of rewriting the whole machine learning library for R. They have basically wrapped MLlib. So everything falls into play. Okay. So I will try to draw the diagram of how you should think about it. So imagine that you have your RDD here. RDD is a general concept. You can manipulate it using Java, it using Python, and it using Scala. And okay, so okay, so you can manipulate it using Java. Okay, and here along with the RDD, there are some libraries written. Okay, or you can think it the other way as well. Okay, so you can think it this way that all right, so Scala and and Scala plus Scala and MLlib. Okay, so from Java you can call this whole stack, and as well as you can call this stack from both of the, or should I just make it smaller? Okay, so yeah, so as a user you could use both of them, and even if you are from Python background or say R background, you could talk to R would be basically talking to both of them. Okay, and user can either write Java or R. All right. Okay. So in case of Spark R data frames, a data frame is a distributed collection of data organized into named columns. It is conceptually equivalent of it is conceptually equivalent of it's conceptually equivalent of a table in relational database or an RDD. Okay. So to start up, I have already written this part. Okay. So I have created, okay, since Spark, the one which we had by default, was not providing us, it was not providing us a way to talk to the older Spark which we have on our server was not having Spark. The default version of Spark, which gets installed by Ambari, does not have SparkR. Therefore, we have installed our own newer one on the console window. So I have already logged in here. So let me try to show you. Let's try to show you. Okay, so you can start. All right, it's taking time. All right, so it has started, but it has started in the standalone mode. Okay, if you want to execute it in the yarn mode, you can say things like this. Okay, but for that you will have to set the Hadoop conf directory to the Hadoop folder. Okay, all right. Now once you have started your Spark here, you can see that the version is 1.5.2. Okay, that okay, that's a little newer. The one which we had earlier seen in Spark, well, that was 1.4. All right, now the entry point into Spark R is the Spark context. Okay, that is the entry point into Spark R. All right, so by default when you launch the Spark R from the command prompt, These Spark context and SQL context are already created. Okay, they are already created for you, so you don't have to worry about it. Okay, so as well as the other part you need to do is you need to start the SQL context. One is Spark context, then you create the SQL context. These are the two things you need to start before working on it. Now, when you are launching from the console, you don't require that. Okay, but if you are saying, let's say you wrote this script in a file and then ran this Spark R against this script, then you would require the Spark context object. Okay, and the SQL context object. By default, as you can see that Spark context is available as SC and SQL context is available as SQL context. Okay, so this console has already done these two things for us. Good. Next is let's try to create data frame. That is the first step, whether we talked about Pig, Hive, and SQL everywhere, because these operations, when we talk about big data, it's all about data. So the first thing we do is we load the data. So first thing we do is we load the data into a data frame, or we call it creation of data frame. A data frame can be created based on either the local R data frame. Also, please note that when you're installing Spark R, you need to install R before that. Okay, so that lot of library and data of that R can be is used by Spark R. There are some dependencies There are some dependencies for which it needs to talk to the locally installed R. Okay, so either you could create data frame from the local R data frame, or from a Hive table, or from other data sources. So the Hive table which we created yesterday, okay, we could use the same table in the as a data frame as well. Okay, all right, so you guys have an idea about a data frame, and you have an idea about the Hive as well. Okay, okay, so next is that the other data sources could be the third point, the other data source could be from the local file system like JSON, or from an SQL database located remotely. All right, now this is probably the most simple data set. And what is it? It's basically the eruption of it's a eruption of the, what do you call, there is a volcano eruption called Faithful. There, and and based on that, there is a lot of data that has been gathered of those volcanoes. So it's the name of it is the Faithful or something. Okay, so it is that data, it comes in R by default. Okay, it comes in R by default. So you can load this saying d either okay, saying df greater than, this is assignment, df is create data frame. Okay, so the data frame has been loaded as an RDD. Okay, internally it's basically, if you see, the partitions are being created, and it's basically an RDD. Okay, you can see parallelized correct collection RDD. So that has been created internally for us. Okay, So for this, while it looks like from this prompt, it's like data frame, okay, containing two columns. One is called eruptions, and other is waiting. Let me see if we can access it. No. The way you have to access it is, okay. So, all right. Let me try to access it the way we were accessing it earlier. Okay. You can see we were able to just see the few records from this table. All right. So this way we are able to load data from our R dataset. These are the dataset that come with R. Okay. Sounds good to you? Now, Mehdi's question is, okay, let me save it. All right, let me just save the class notes. All right, I'll try to do. All right. So question here is, can I use streaming weblog file as a source data for the data frame input? Can I use streaming weblog file as a source data for data frame input? Okay. Mm, all right. No. So what you want to do is you instead of because here it can analyze the static data, but it'll be difficult to execute. So basic question is, can R talk to the Spark streaming, right? Is that your question, Mehdi? All right. As of now, no. But that's a very interesting question. That's a very interesting aspect because while working with streaming as of today, I had to write a lot of code, okay? Unnecessary code. So if somebody could make this happen, it'll be wonderful. And I would like to work on this either SQL over Spark Streaming or R over Spark Streaming, meaning every second I want to execute my R code on top of the Spark Streaming, on top of the window which is being created every second, right? So I'm not sure if the uh, basic Apache Spark has started executing the R, but it is worth a try. Okay. So far, as far as my knowledge says, the R program cannot be used in the Spark streaming. Although Python program can be used as Spark streaming, and Java program can be used in Spark streaming, but I'm not sure about Spark streaming. Okay. I'm not sure about R being used as Spark streaming. All right. So in the previous example, we basically loaded the local data frame from the local R, and we were able to see the data, right? We were able to see the data. In the second case, I want to load one JSON file. Okay, I want to load one JSON file. Let's have a look at it. What is there in this file? All right, what is there in this file? In this file, you can see that the data is in the form of key value pair. Okay, you can see that it's basically a JSON, right? It's a JSON which has curly brackets and key colon value, comma key colon value, and so on. So it's basically a JSON. So we can load a JSON data, JavaScript object notation data, and what did I do? Yeah, okay, using, yeah. Now you see people is a data frame. Okay, I can say had people. All right, now you can see that the it has given the all right, now it has given me the detail about the people in that table. Now if I want to compute, if I want to the find out the summary of the age. Okay, okay, and that's my age. If I have to say print age, all right, if I say had age, what happens? Okay, good. If I say summary equals to summary of age, and what is the summary? Okay, now you can see that summary has been computed as this value. Okay, it was waiting for, I think you call print. What do you say? Yeah, S, and I say, all right. So you can basically see the head of summary, and it contains all the details about our data. There are two records. Their mean is this much, standard deviation is this much, max is this much, min is this much. All right. So basically, we loaded the data from JSON, and then we ran our R queries on top of it, and then we saw what is there inside it. Okay, so we can quickly examine data from various sources, just like the way we did with normal R. All right. Okay, so next is that we can also, that is the beauty of Spark. They took care of uh, creating everything. Okay, in the sense that they took care of uh, connecting with every kind of data source, and that is the quality of any analytics tool. The quality is that it should be able to communicate to every kind of data sources, otherwise it is useless. Okay, so SE is an existing Spark context, and as we talked about, but this one you will have to create. Spark context is something you will have to create. Now here, what do you see here is we are saying execute this query in Hive context, meaning execute this query, which is basically creating a table called this one into Hive context. Okay, so this will create a table in Hive. Then this will load the table in Hive. And if you already have the table in Hive, you can basically you can basically you can basically query the table from Hive using from this is your table name, select this column and that column. This way you can query Hive tables from R. Now, as soon as you query, you will get the data frame. Data frame is an equivalent of a database table, and therefore there would not be any problem with this. And once you say results this, you get the actual values from Hive. All right, that's how you can talk to Hive. All right, next is that you can create the after you have created the data frame, you can do all kinds of what do you say, all kinds of operations which were given in R. For example, what am I doing here? After I loaded this faithful data set, okay, after I loaded this faithful data set called df, okay, it got two columns. One is called eruptions, other is in waiting. Next, we could, yeah, next we could do is we could just select things from eruptions and notice that these all computations would be happening on our RDD. Okay, these all computations are happening over our own RDD. Head gives us the initial few data, but you can save the same data to any location using a command from R called save. Okay, that way you can talk to all kinds of databases and you can churn the data using data frame. And please notice that any operation we'll do, it will automatically decide how to execute it over our cluster. Okay, all right. The other data frame operation here, the operation we did was select query. What we did was out of df select only one column. If there are 20 columns, it'll just pick only one of those. Only one of those with the name called eruptions. All right. Next is we can, after we have done selection, we could also do filter. We could say, give me those records which are waiting for less than 50. Okay. So these are the eruptions which are waiting for less than 50. Basically, top six of those. All right. Next is that we could also we could also use the n operator to count the number of times each waiting times appear. Meaning we could do kind of histogram generation using summarize summarize. Okay, we could say summarize and then you can say group by and then. Okay, all right, so it creates kind of the what do you call, kind of the word count. So when we say n, it basically so if you say n of what do you call here, n of df dollar waiting. Okay, so it basically does the computation. Okay, so yeah, all right. How do you print a data? All right. So basically, you can do various kinds of operations like grouping and aggregation using Spark R the way you did in R. All right. We can also sort the output from the aggregation to get the most common waiting times. Okay. Here we could arrange the word count into decreasing, and then we could pick up the records from there and then summarize. Okay, so that should give you a good enough confidence that most of the operators which were there in the older R are there in Spark R. Okay, if you want to convert, you want to add more columns onto your data set or data frame, you can simply add that. Just like here, we are saying df dollar, then the column name equals to df dollar column name into 60. And if you see, had df before this had only two columns. Now after this, it'll have three columns. Okay. After this, it will have three columns. You can see one more column has been added to the data set. Sounds good to you? All right. So basically, you can execute all kinds of operations which you did in R using Spark R as well. All right. Sometimes you are not very comfortable. Sometimes you are not very comfortable using R. Okay. People like me who are not very uh, confident with R, but who are very confident with SQL, they can use SQL instead. Okay, those who are fluent with SQL, they can use SQL on top of a data frame. Okay, the only thing you have to do is they have to mark it as a table. So once you mark it as a table, then the magic starts. So let's see. So what is it? So this is something which is very interesting. So when we say people is a data frame with two columns, age and the name. All right. Now what we do is we say that let there be a table with the same name called people. Now once we have created that table, now we can use SQL context and query in the SQL context, and that all of this is happening inside R. So we inside R we're using SQL to clean up our data frame. So that means that whether you are from R background or from SQL background, you can pick and choose which thing you want to do when. Okay. The some people like the way aggregation operations happen in R. Lot of people do not like it. Okay. For them, this is a very beautiful use case. Okay. Now you can see that. All right. You can see that it's just fun. All right. So that's the beauty of Spark R. Okay. So the fitting of generalized linear models over data frames is something which comes into machine learning. All right. Now, is that clear to everyone so far? What we have talked about how to load the data and how to do the usual aggregation operations or filter kind of operations. Okay. And so if you are registering multiple tables, you can do the join between them as well. All right. So from R, you can load all kinds of data. And then from R itself, the same data can be cleaned up using SQL. If you are not very fluent with R, you can use some part of R, some part of SQL as per your choice. You are not bound by that. So this is like kind of a hybrid data journey. Okay, but this gives you enormous amount of capability and more expressive way of doing things. Some part of the data are well churned using SQL, some part of the data is well done using R. Therefore, this small syntax of SQL makes a lot of sense. All right, so we had talked about machine learning like clustering and the high-end machine learning like clustering, the two kinds of clustering, but we did not talk about linear regression, multilinear regression, although we took an example of regression. So there are many ways of fitting a curve into the given data. Okay, there are many ways to fit the curve or the three-dimensional surface into a given data. Okay, one of them is Gaussian, and there are a few more ways to do the curve fitting. All right, now R provided us functions like LM and GLM. This is called generalized linear models. Okay, so fitting of generalized linear models over data frame using GLM function is something which has been done in SparkR so far. And there are few more parts to it. So anything that can be done in machine learning that can be called using R. Okay, all right. So currently as part of this generalized linear models, Gaussian and binomial families are supported. So as I was telling you, when you have to fit a graph, there are many techniques. Two of them are Gaussian and binomial, and these two are supported in Spark R machine learning. Okay, so under the hood, Spark R uses MLlib to train the model. Train the model as in plotting a graph, okay, of the specified family. Okay, when I say creating a graph, it's a symbolic meaning that it is understanding your data. Currently, the Gaussian and binomial families are supported, and support for the subset of available R formula operator for model fitting is there. So this tilde you see here, this is used in model fitting in R when we want to show the dependent and an independent variable. Okay, so I'll show you in a minute how to use these operators. Now let's have a look at one data. All right, so what is this data about? This data is about the predicting the models. This data is about predicting the model, predicting the various flowers based on their sepal width, their species. Okay, all right. So here we are saying, so you can see that what we are saying is we are loading this data called iris data. Iris data is basically the data of lot of flowers. The data of lot of flowers, which contains few things like length of the sepal, width of the sepal, length of the petal, and width of the petal. Okay, and then one more column called species. All right. Now, if you say summary and what do you say, df, okay, All right, how can I make it print? All right, so this is the information about species, and total count is this. All right, all right. So basically here, so you can see that the sepal length is this much. All right, and total species are 150, and there is Setosa and Virginia, and so on. Okay. All right. So basically, what is exactly are we trying to do? We are trying to fit a linear model over the data set. Okay. What does this GLM do? You can have a look at in R. Okay. So in usual R, it basically it basically makes it possible to plot a graph of a function or fit a graph where x1, x2, x3 are the predictor, the input values, and f is the output because of x1, x2, x3. This is not summation. This function, this when we say in GLM, when we say in GLM that, okay, let me just go back here. When we say in GLM, all right, when we say in GLM, sepal length tilde sepal width plus species, what exactly we are saying? This one is a this one is a dependent variable, and this column, these two columns are the independent variable. What exactly are we saying? Predict this based on these two variables. So if somebody will give me these two variables, I'll be able to predict this length. Okay, so I'll be able to predict this length. That's what it means. Okay, so you can simply create a model, out of it. Okay, and then use this model to do the predictions of the future. Okay, so all right, all right. So this is how we generally. So once we have generated the model here, okay, we are trying to see the, okay, all right. Let me try to do some things. So model is our data frame, which is the result of churning this one, and then we can say model dot fit. Oh, we can't say model dot fit. There would be a way to. All right. So this model could be used in many ways. Okay. So you can do the predict method over the model and say, okay, so it has, these are the predictions of sepal length based on the past data. Okay. So you can see that it has done the prediction. The actual length was this, prediction is this. All right. So what exactly we did, we'll just take a step back. All right. So let me explain from the beginning. First, there is some data called iris data. This iris data is, you can have a look at it here, is basically is basically flowers data. This flowers data has the length of the sepal, length of the petal, and based on that, it has the relationship of the species. Now, what the author has here, what exactly are we trying to do is we are trying to combine the width and species and predict the sepal length. Okay, predict the sepal length. Or we could have done the other way around as well. We could have taken species this side and we could have taken sepal length this side and try to predict species based on the input. Okay, so we prepare first. What we did was we prepared the model. We gave it the whole data. We gave it the whole data and said, prepare the model. And once the model is prepared, then we applied the model on the same input data and cap the predictions uh, and then have the predictions. Then once the predictions are ready, we got two data set. One is called predictions and other is called the DF. Okay, so we are saying in the prediction that select predictions from from predictions, select sepal length and a column called prediction. The predict method generates a data set which gets all these columns. So you can see here. So you can say head. Okay. So you can see that. Why doesn't it show things? Okay. Did it actually run? No. This cannot be done. Some error. Why? All right. While this method is correct. Oh, why is it so? It can't do it for all columns. All right, never mind. So what we have seen here is predicting the sepal length based on the width and the species is the actual was this much and predicted is this much. Okay, you can see that. You can see that. All right. Now, if you want, we can basically ouch, predictions. That is our predictions. Now, out of this, if you want to just take out the actual width and what was that sepal length, we can take out from this. We call it SL and we call it predicted. Predicted equals to okay. Predicted is to be all right here. So we have got SP and we have got P. Now, the slight difference between this and our usual one is that by default, when we did in RStudio any variable, it gave us the any instant result. But here we have to fetch it explicitly. The way we had to say take 10, in the same way we have to say head and then get the data. Okay, So does it have a variable called collect? See, so collect works fine. All right. So we have collect and we have P and SP. So SP is the actual. This is SP is the actual and P is the predicted. Now, if we want to say SP minus, sorry, SP, yeah, SP minus P, okay, and then we say square, or we could say, okay, so this is diff, okay, a non-numeric argument to a binary operator. Do we need to write like this? Non-numeric argument to the binary operator. Alright, looks like we can't. Alright, I need to have a look at it. Okay, this is how it worked in our R. Alright, alright, so okay, let's take a look at it after the break. Alright. So anyway, so we are able to see that the predictions are very close to the actual. Okay, the only thing is same data we trained and we are testing our model against same data. Why? Because our data is relatively small. Okay, if our data is relatively bigger, then we can do the prediction for the missing data. Okay, we can do the prediction of missing data. All right, here since if now what we do it in general case of machine learning, we compute the standard deviation here, and we compare the standard deviation by using different models. Here we are using Gaussian, then we can also use binomial, and in some cases we could go for other machine learning algorithm. So what exactly are we doing? We are trying to predict sepal length based on the width and species. First, given the full data set, we we computed the model, and then we applied this model on this data set. Although in this case it's the same data set we are applying, so that we can compare effectiveness of our model. If our model is really effective, this delta will be very small. Prediction versus actual is very close. Okay, so basically what exactly are we doing here? We are asking the asking the astronomer about our actual past. Okay, that's what we are doing here. So we are saying that tell us about sepal length, and we know about sepal length. Okay, based on the full situation, and then comparing. So after comparing multiple such algorithm, you will have the standard minimum standard deviation for the best algorithm. Okay, so for that you have to try out couple of algorithms such as Gaussian, and there are few more. All right, there are few more. So that's pretty much with respect to SparkR. You can continue using and trying to do the predictions. And all right, so is everybody with me on this? Great, great. So we were able to read the data from Hive, from JSON file, and from the local data set. Okay, and we were able to apply a machine learning algorithm on top of this data. So you can, and we were also able to use the various filters and aggregation. All right, so these are the basic functionalities provided by SparkR, and these functionalities are good enough to do a lot of things. Also, we talked about how do you execute the select SQL queries on a data frame. Okay, these are the very powerful uh, constructs of Spark R. All right, so that's pretty much with the Spark R. After the break, we will talk about Mahoth, MLlib, and Mahoth, MLlib, and GraphX. Okay, all right, let's take a break for 5 minutes. Back by All right, so we can start. Anusha and Mehdi, are you back? Great, great. So, all right. So that was uh, the example of prediction using R. You must try this kind of prediction. You should try with the width instead of length. Okay, you should try with the width instead of length. Okay, the other way to do is that you out of this DF you select first 10 records or first or random 100 records or how should I say. Okay, so out of this DF you should basically, generally when you have a data set, you are given two kinds of data set. One one that will have length, and the other that will not have length. You will have to predict the length of the that data set. You will be having only two columns in that data set. Okay, so that's how most of the predictions work. All right, so that was an example of machine learning. So what kind of machine learning we have talked about so far? We have talked one about clustering. That's what we did earlier. Today we did multivariate linear regression. Okay, and or linear modeling. You call general linear modeling. Okay, so in clustering we have talked about two kind of clustering earlier. One was hierarchical and other was, okay, so the other clustering was the what was the other clustering? Other clustering was normal k-means. Okay, we today we talked about GLM. Now, uh, okay, so GLM was done in Spark. Okay, basically having uh, generalized model. If you have say 500 variables with 500 columns, and the you for some of the data is missing, you can use GLM and it can fill that data. Now, k-means and this clustering we did with simple R, right? Now we will also talk about few more examples of machine learning. All right, with different tools. So it's not that this can't be done in normal R. Of course it can be done. Or the hierarchical and k-means both can be done using Spark R. Okay, I'm just taking that kind of examples. All right, let's talk about something called Mahat. We will talk about Mahat in a very quick manner. We have already talked about machine learning, or have we talked about Mahat previously? Did we did we do recommendation engine using Mahat so far? No? All right. Let's try to build a recommendation engine using Mahat. All right. All right. So earlier, before Spark came into play, there was only Hadoop MapReduce to handle mammoth amount of data. Mammoth as in really, really huge data. At that time, if somebody has to do machine learning, it was almost very deep. The only tool to go to was Mahat. Mahat was a machine learning library. Unlike R, it was scalable. How? Because it ran you in the Hadoop and using MapReduce. So there was the NGETL wrote a paper called MapReduce for Machine Learning on Multicore. Okay, and that paper, it was the basis for Mahat. It became quite popular and was quite useful as well. And for that matter, Mahat was my Mahat was my reason to use MapReduce. Okay, so when I was building the recommender for InMobi, where given the large corpus of their okay, so let me take a step back. Let me tell you the complete story. So what is InMobi? InMobi is kind of an ad platform. It's an ad platform, and what does it mean? When you play a game, okay, so the game programmer, the owner of the game, has embedded an advertisement widget in your game. And from time to time, it displays an ad. So this widget is nothing but a very small browser which keeps hitting the InMobi server and keep on getting the ads from the InMobi server. So InMobi acts like a ad vending machine. As and when the request from this user comes in, it sends the ad. But the important part to note is that InMobi knows which game were you playing, because this request sends all the information about your phone and the app. It informs that what is the game you're playing and from which IP it's coming. All of this gets recorded in the web server logs, access log specifically. So so we had this nice access logs. Okay, so a person is playing the games. Okay, let me keep on drawing so that you don't lose interest. So so here is let's say this is your mobile, and here is some, let's say, some okay, why can't it be this way? All right, so and here let's say some game is being played. This is some game user is playing, and here is the ad. This is the ad. Okay, and this ad and I have really made a very bad mobile diagram. Okay, this is your mobile. Okay, and this is the ad. This ad is making a call. This ad is making a call to InMobi. Okay, this is InMobi web server. Okay, and every time it makes the call, it generates kind of logs. Okay, it kind of generates the log. This is the logs which are being generated by the web server. Okay, and these logs contain lot of information about all the user. Now out of these logs, okay, out of these logs, what do we want to do is we want to compute. So also please note that here there's a user identifier everywhere. We want to say user one has played this game one, say 1,000 times. User 2 has played this game as 500 times. So once we have this kind of data, after we clean up, so we cleaned up this data using Pig, and we got this information that this user likes to play Fruit Ninja, and these many times he has played so far, or these many seconds, based on total number of requests, and we computed their level of engagement. Okay, so based on this we were able to cleanly predict that which user is playing what game. Okay, now based on this, and there were like And this data which was here, it was close to 200 TB. Okay, close to 200 TB. Now you can imagine that it will take 200,000 seconds, or you can say a thousand seconds, as in a million seconds, to read this kind of data. Okay, but we had lots of machines to clean up this data. So cleaning up this data to this form was little tricky, and then we did a kind of normalization, so that we converted into something like between we normalized it, and we converted it something between 0 to 5. Okay, here first we created something like time, user, and game. Okay, also note that here we did one more filtering. We removed every other country than the US. Okay, we removed all the countries except for the US. Okay, the time 2, U1, and G2. This kind of data. All right. Now, once we have this data, we will be we will be taking this data and generating the recommendations. There are two kinds of recommendation: game to game recommendation, as in all the people who played this game also played that game. Other kind of recommendation is people who people uh, I mean user one would like to play this game. So this, from here to generation of user data, u1 and u2 data. Okay, I mean they will like, user one will like to play u2, say 5 out of 5. Okay, and user one will like to play this data 4.5. Okay, so user one will like to play this much. So this is recommendation based on us history of the users. How much will they like to play some. Okay, so this is the recommendation we are going to generate today. All right, so but today we are going to do, I think, yeah, so this is basically what we have in mind today, and we have already covered basics of machine learning already while talking about R. Okay, and yeah, so this is what we're going to do. All right, we are going to do the recommendation of the movies. We will be given the person and the movie and their ratings, and from that, using Mahat, we will be computing the ratings. All right, let's try to launch it. Okay, the first step would be we download this data. I already have downloaded this data. We can use Pig to clean up these records. Okay, we can use Pig to clean up this record. What am I doing here? First, I am loading this input data. Where is this input data? This input data is in Hive. Okay, so no, not here, but in file system. Okay, so we have data here, and inside data we have what we have here. All right, what we have, where did it go? Here. So it would be somewhere here. Okay, so you can see that. So I have already downloaded this movie lens data. There is a website called Movie Lens, from where you can download the public ratings provided by various users. Here it also shows you the details about the users. You can see that it's a female, this is a male, the age is this much, and rest of the criteria. Okay, but we are not going to touch upon the other aspects. All right, now we have got sorry, ratings.dat. Okay, ratings.dat. Ratings.dat contains the column separated data, but we want to first convert it into comma separated. Why? Because Hadoop, Mahat wanted that way. Okay, we'll have to convert it into comma separated. So what we do, we will use the pig for doing the same. All right. So we will use pig to load the data. Okay, by column separated. Then we'll generate the 0, second, and fourth column. Why? Because column number 1 is empty, because our data is in the form of is double column separated. Okay, and then we will store this data, clean data, into ratings.csv. All right, launch pig. Let's launch pig, and here we go. So it says that, okay, the directory already exists. So I will store in some other directory. Let's call it BDA directory, ratings BDA. Okay, this is a directory, so we don't have to put .csv. Okay, so it would clean our data and make it comma separated. All right, in our home folder. Sorry, I'm into somebody else's account. All right, so we could go to, okay, so there would be a folder here. All right, all right, so here we go. So you can see that the data is ready in the form of comma separated. Now we can feed it to Mahat and we will get the results. Okay, how do we feed it to Mahat? We'll just have to export this. Okay, okay, we exported it, and also we'll delete the old folders from my HDFS one because it would be existing. Then we are saying Mahat recommend item based, and then this is the algorithm, and this is the input file. You can see input here we'll say BDA. Okay, BDA, that is a folder name, right? Ratings BDA, ratings BDA, correct. And we'll say output is this. Okay, so by default it takes the folder and puts the output in this folder. Okay, now let's start. All right, it will take considerable amount of time because data is 1 million records. All right, data is 1 million records. Such kind of possibilities are bleak when you want to do it using R or any other single machine systems. Okay, so it has started the work. And you can see here that it's basically combination of many map reduce cycles, at least 6 7 map reduce chain. Okay, so first one has finished, second one has started, and a lot of things will happen in parallel. Okay, so that's what is happening. Once it is done, it will store it in this folder called recos, recommendations, and in this particular file. Okay, in this particular file. All right, so there are these other algorithms. You basically try all of these and see which one is giving you better results by comparing the recommendations against the actual behavior. Then you will pick up the one which is giving you better results. Okay, all right, good. So let it finish. Let it finish. So it's going to go for quite some time. But in the meantime, we can talk about the other aspects of Spark. So we're going back to Spark. We talked about Spark R. We went to Mahout. Mahout is an old system, please keep that in mind. Mahout is something which was on the MapReduce. Mahout is great when you have terabytes or petabytes of data. It can handle that kind of thing because MapReduce can handle that. Okay. But if you want something quick, if you want something quick, which is uh, so then you will have to go for tools like MLlib. All right. So the goals is to make the same thing as other machine learning libraries. Okay, so Mahat was the machine learning library on MapReduce. MLlib is a machine learning library on Spark. Okay, so so the goal of MLlib, like R and everybody, is to give the machine learning of these various kinds: classification, regression, and clustering. Classification is the one which we did is kind of predicting the doing the linear regression, which is linear modeling, GLM, which we did. Sorry, sorry. Uh, Classification is classifying the data into various buckets. Okay, based on the past history. Then the linear regression, then clustering, then collaborative filtering, and dimensionality reduction, as in figuring out which variable is independent and which does not have any impact on other variable. So that is dimensionality reduction. So and then MLlib also provides you various kinds of optimization primitives and also something called the high level pipeline APIs. Okay, so Spark has got two packages. One is called Spark MLlib. It contains the API built on top of RDD. Okay, and Spark ML, which provides the API, a very high level API for machine learning pipelines. Okay, so it defines new kind of data types such as vector. Vector is similar to the vector in R. Labeled point is something very new to machine learning. Labeled point means there is a value and there is an array of, so there is a label and there is a what do you call vector. So giving a name to the vector is what is called as labeled point. Okay, and why is it important? This is important because if you think about any prediction or any modeling, okay, it's generally saying that there is a label for it. There is a label for it. For example, imagine imagine we are trying to predict the handwriting analysis. Okay, we are trying to predict handwriting analysis. Let's say A. Okay, so the vector would be an array of all the decimal points. Okay, a vector would be all the decimal points, and the label will be the name which is being represented here. Okay, so or you could say the array could be the all distinct words that are existing in a vector, all right, and the name would be spam or not spam. So label point is the label which our input data has for a big vector. So label point is a very good data type, because in almost every machine learning problem it's all about prediction. Okay, and label point makes a lot of sense. Other than that, there are many ways to represent a big matrix. So whenever we are doing the predictions, whenever we are doing the regression, mostly it's a matrix multiplication. And when we say matrix multiplication, that means that we will have to do all kinds of matrix manipulations as we go forward. But since most of the data types in case of Spark is actually RDD under the hood, therefore the matrix will have to be converted into an RDD. Okay, and those are the various ways of representing a matrix in RDD. For example, the index row matrix. What does it mean? It means we we convert the full matrix into xy value meaning row number, column number, and the value. We convert the whole matrix into three columns. Okay, so that's the various representations of the matrix that you want to use for your data. Although it's not for general use, and MLlib also provides you the basic in statistics, such as summary statistics, correlations, stratified sampling, hypothesis testing, random data generation, and kernel density estimation. Okay, sometimes your data has a kernel, and kernel means imagine that imagine that your data is in the form of, let's say there is a lot of data like this. Okay, and then there is a data here. So in these circumstances it becomes very difficult for the prediction, and therefore you need a different kind of algorithm to do the prediction for the tools that have kernels. Okay, so these are all required when you try to figure out which algorithm to use for prediction. Okay, so you can do the various computations from using PySpark as well. So you can say summary equals to statistics dot call stat and given a matrix. All right. So MLlib also supports the various methods for classification. It provides you the binary classification, and so it provides you the linear support vector machines, logistic regression. So almost every, if you are into machine learning, you may want to go into the details. Okay. So MLlib is a collaborative filtering tool. It it is commonly used for recommender systems, which we have already talked about, and it provides you the techniques which aim to fill in the missing entries in the user item association matrix. Okay, missing entries as in the values whether this person will like this product this much. Okay, so MLlib provides you a very good collaborative filtering or recommendation generation. Collaborative filtering and recommendation generation both are the same things. Okay. And MLlib uses the alternate ALS algorithm to learn these latent factors. Latent factors, as in users and products, both are described by small set of latent. Instead of user being described as a number, user is described as a factor. Or you can think about it, user could be male of this age and working in this industry. Product could be movie with the director name this and actor name this, released in this year, and genre is this. So those are the latent factors that could be described in, that could be used while doing the collaborative filtering. All right. Next is that here what we try to do is here is trying to use the collaborative filtering example here. Okay, so we can load using PySpark this particular text file, this our test data, and then load, we split the data. Let's try to do this. Okay, so output directory already exists. What happened to this? Didn't we create already? Didn't we delete it already? What is the problem with this guy? Output directory records already exist. All right. Okay. Oh, we did not delete records. Ouch. All right. Let it go on. We will open another e.cloudxlab. Okay. And the login password is here. And all right. Now let's start with PySpark. So MLlib is not a separate language. MLlib is just a library which can be used from Java, Python, Scala, okay, as well as from R. Okay, so moving on. Here you can see that we are trying to load this data, but I'm not sure if the data exists. Let's try to take 10 records from it. It says the file does not exist. Okay, so what we'll do, we'll try to locate this data. Okay, let's try to locate this data. And where would it be? It should be somewhere. Let's first find out where is our PySpark coming from. PySpark is coming from bin PySpark. And when we see what is there in bin PySpark, this is where it is. Okay, so we go into this folder. Okay, so here is our data. You can see that. So we can use in our examples this particular data folder. All right, and we can change the code accordingly. We could change the code accordingly. We could say this. Okay, now let me just check if it exists or not. Alright, it does exist. Good. Now let's go back to PySpark and load the data this way. Okay, we will put it like this. Alright. Also, let me just update my example here so that we don't make mistake again. Alright, now let's check if we have got any data by doing take. What does it mean? Ouch. It's trying to find this data in HDFS. Should we upload it in HDFS? Okay. I could say Hadoop fs copy from local, and what is that location? Location is this. Okay. And let me just upload it into my folder. What did it do? Yeah. So I think it has uploaded. I think it has uploaded into my Hive folder. Will it be possible to extend today's session by 30 minutes? Today, okay. All right. Although it's a small data, but never mind. Okay. All right. So we are trying to load the data for this. And what is the folder name, by the way? Folder name is this. Okay. Let's just try to take the data. What does it say? Okay. All right. So we have finally loaded the data. Okay. And then here we are saying, let's just say data.take. All right. So this is how our data looks like. Every element is comma separated values, that too string. First, let's convert it into, let's first split it. We are saying here, first we are splitting by comma. Okay, you can see L dot split. Then we are creating something called a rating as an object. Okay, we are creating rating as an object. All right. So now ratings has been done, and you can see that every object is okay. Rating have to be imported first. Okay. No module named numpy. Import numpy. Do I need to install pip install numpy? Ouch, I need to get into the root mode. Alright. Alright. So since we have not installed numpy, this we are not able to run, but we can run it. And again, once we have prepared the ratings, we can generate the model. This is the input data which we have created in the form of rating objects. It's nothing but a list of rating models. Now we generate the model of the ratings, and then by saying als dot train, this is our rating. This rank as in So number of iteration, how many iterations should it go, and rank as in what do you call the total number of total number of uh, so okay. So this one by default uses number of iterations and trains using this input data, and it generates the total number of rank as 10. Okay. And then once the model has been generated, on top of the model, we can do the predict all. Okay. So predict all, what did we do here? Same data again, same input data, we removed the rating. Okay. And predict, let this model predict the actual rating by the users. Okay. They'll give us the prediction of the same movies. Okay. Now, this kind of mode of working where we prepare a model and then keep on predicting using it is very useful in the sense that we can do the same thing in the real time environment. If the orders are coming in real time, you can use the same model inside the Spark streaming and keep on predicting in real time. Okay, and that's where this model predict all comes into play and is very useful. So you generate the model in the morning every day and use the same model whole day. Okay, you don't update the model every second or every minute because updating the model takes a lot of time, while applying the model or predicting the model based on model is far more easier. Okay, so here we are saying prediction equals to model.predict all. This is the input data, and then we are cleaning the records and returning from the ratings these three array values, okay, as the tuple. And once that is done, we are joining it with the we are joining prediction with the actual input data, and then we are comparing the standard deviation. Okay, this is basically the error, comparing the actual versus the predictions, and then we are saving the model in the output folder, and that's all. Okay, so you can try both of them. Okay, the numpy will work, we just have to install it. Okay, so we will make it work. All right, next is clustering, same thing what we did in R. Okay, same thing as we did in R. There are multiple kinds of clustering: k-means, Gaussian mix, PIC, LDA, and streaming k-means. Streaming k-means as in k-means applied to fast incoming data. Okay, so here's an example of doing the k-means. Import these. Let me see if these. Okay, so now this Mahat is done. We'll take a look at the result. Okay, so we'll say Python. Does it work? No, we have to install those modules. Okay, we have to install those modules on our machine. All right, so let me just check with the. Okay, I'll just put a to do at the top. Okay, this one, and what was the third one? This one. All right, these four things have to be installed on this node. All right, so that was mllib. So and also you can see a very good thing about using PySpark for with mllib, that all these methods which are part of NumPy can be used inside your logic. NumPy provides you various mathematical operations and various mathematical data types which you can use along with mllib. Okay, so basically there is a k-means data. The way we did the segregation for our R, exactly in the same way. We loaded the data, we passed the data, cleaned the data. Here we are basically going in the loop, cleaning the data, and then we are saying k-means dot train. Okay, this data and we want two data points, two groups of data, and these are the max iterations and these are the total runs, and initialization mode is random. We are not providing initial cluster locations. Okay, so that way it will generate the cluster. And once clusters are generated, we can compare. Okay, we can basically compare the distances. I mean distances, the error from the point. Okay, this will give us the results, and we can compare with again with the mean squared value. Okay, all right. So you can go through these if you are more interested in MLlib. You can go through these more URLs and generate it. Okay. Also, it provides you the GraphX algorithms for computation on graph, and there are many kind of GraphX examples. One is PageRank. If okay, so GraphX basically extends RDD, resilient distributed data set, for graph representation. Okay, basically graph data it creates a new data type called GraphX, and on top of GraphX all the computation happen. Okay, it provides a set of fundamental operators such as joining graphs, joining vertices, aggregated messages, and most, I mean, for us as a user of GraphX, what is important to us is doing the analytics on top of graph. And what kind of analytics is possible? Find out the ranks of various people in your network. Given that let's say you are running a company where A customer refers to B, customer refers to C, customer refers to D, and so on, right? And you want to find out which customer has got the maximum value. Now, in that case, you can actually apply the same PageRank algorithm as what provided by Google. Similarly, if you have a larger set of data of your consumers, you can also figure out how your users are connected to each other. Okay, so there are many more ways of using these graphics algorithms. Okay, so triangle counting is something which is done in graphics, but it is used in more ways than imagine. Okay, so you can basically compute the page rank in the following manner. Load the data in the first here. You can see here we're loading the data. Then we are giving the page rank to everybody as 0.00. Okay, so here okay, so we loaded the graph and then we are running the page rank. Okay, running the page rank by initializing with this much value. Okay, so and then once that is done, we are just comparing it with the real one. Okay, and then printing it. Okay, so it's very straightforward. As you can see in GraphX, using a page rank is very straightforward. You can just load the data. So this is the data containing followers. Okay, and this is the name of the users. We are joining it with that, and then we are printing them. Okay, so that's pretty much. So the main crux of the game is in this line. Okay, so you can use the graphics algorithm in a very simple manner. Load the graph and run various algorithms. Okay, so that's pretty, because these libraries make our life really simple. All we have to do is learn, go through the API, use the function which we want by feeding the data it wants. Okay, so that's pretty much about graphics algorithm. A quick assignment to all of you a quick assignment to all of you. I'll share this data with all of you. The assignment is related to the sentiment analysis. Okay, so your objective is to find the sentiment analysis, and for that I will be sharing with you. I'll be sharing with you. I will be sharing with you the where is the project? Okay, let me. All right. So I'll be. This is the one where you can do the sentiment analysis of the word called Iron Man. Okay, all right. So I'm just pasting it here and also in the chat log. Okay, so your objective is given this data, given this data to all of you. Okay, you have to generate the sentiment analysis. And what kind of data do we have? If you go into the data folder, okay, if you go into data folder, all right, if you go into data folder, there you will find the sentiment files. Okay, there you will find sentiment files. Here the data has been uploaded into upload. These are the two folders of interest. Okay, these are the two folders for interest to all of you. Okay, so here is your data. Now first is the tweet. So what exactly are we trying to do? We are trying to compute what has been the behavior of the users over a period of time towards the movie called Iron Man. And this behavior is coming from the tweets. So we basically pick up each tweet and find out whether the tweet is negative or positive. And how do we do that? By picking each word of the tweet and comparing against dictionary of emotions. Okay, there is a dictionary in the same folder that contains the polarity of each word. So for each tweet, we sum up the polarity of each word and we compute whether it's negative or positive. This is the data, and this data is in JSON format. So the example which I have provided to you, this is in JSON format. So each tweet is represented as a JSON data. So you can load this data. Okay, you can load this data using Hive, using a particular Survey as in serializer, deserializer, which is also provided here, which is also provided in somewhere here. Okay, inside Hive folder. So here this is the JSON survey which is provided, and this is the query which you have to use to generate sentiment analysis. Okay, this query basically first load the tweet. Okay, then loads the dictionary and then loads the time zone as in a relationship between time zone and the country. Okay, after that it cleans up the tweet by removing unnecessary fields, and then it joins it with the time zone map so that the country of each tweet could be guessed. And after that it breaks down each tweet into word by word and then join that word by word with the dictionary. It's joining each word with the dictionary and then picking up the polarity again. It's wrapping up all words into a single tweet by saying group by tweet ID. Okay. Now we got each tweet sentiment after summing up the polarity. Okay. And that's pretty much. So once we get this tweet BI, which is nothing but it's basically the ID of the tweet along with the country and sentiment of the each tweet. Okay, so this table, once it's generated, now you can access this table in the BERT. You have to download BERT and install BERT. And the way I had described yesterday, that you have to follow a particular document. I have mentioned it yesterday. And then you have to represent it somewhere. Or if you like you to use Microsoft SQL, that's provided in here. All the steps required are provided here. Okay, so you have to first generate that and then also download the latest Hottenworks. This, I think this is little older. Download the latest one. Okay. All right. So that's pretty much. So what you have to submit to me is, first, please submit the Excel sheet. Second, let me know where you have kept your data, the resulting table in which database, and that's all you have to submit to me. All right. So that's pretty much for today, and that finishes the course. And if you have any doubts, please let me know at any point of time. Okay. So please submit I will send you the dates along with along with these links to these documents, and please submit the project on the date. All right. Also, please try to execute each and everything whatever we had discussed in past. Okay. Only then you will be able to experiment with this. This is probably one of the biggest course, and it has we have gone through the entire stack of the technology. All right. So feel free to reach out to me at any point of time if you have any doubts. All right. Thank you, Mehdi. Thank you, Anusha. Stay connected. I mean, if course has ended, it does not mean I mean, we have nothing to do. So you can basically connect with me on the LinkedIn and stay updated. Saying goodbye doesn't make sense in today's world because we will be connected. All right. If you have any questions, feel free to ask me. Okay. All right. So that's pretty much Mehdi and Anusha. Okay. No worries, Anusha. So please attend those, and the videos must be there in the class. All right. For anything, just reach out to me at reachus at no big data. I keep on checking that email. Okay. Reach us at no big data if you have any questions. All right, Anusha. So feel free to reach out if you have any doubt, any questions. All right, Mehdi. All right. Thank you, Mehdi. I hope you like the sessions. I know these are too many things which we have discussed, but we can't help. There are too many technologies. All right. Anusha's question is it possible to attend any other batches? Yes, that is pretty much possible. But the batch for the big BDA, I mean, big data analytics, would be starting after some time. Okay. After some time, as in, I'm trying to take a break for the weekdays because weekdays are a little too hectic for me, and I'm not able to find an alternative for me. Therefore, it will be some time for me to relaunch the course. Okay. All right. But you can reach out to me. Just go through the videos. If you have any doubts, please reach out to me. Reach out to me. Okay. All right. Thank you, Mehdi. Thank you, Anusha. It was great to have you in class, and it was a great class. Sure, sure. We will upload the videos. All right. Thank you very much. Bye bye. Okay, November 30th video is on my to-do. Let me check where is that video. All right, great. All right, Anusha. All right, Mehdi. It was great to have you in class. Feel free to let me know if you have any doubts, any questions. Okay? And stay connected. Yeah, stay connected and send me a LinkedIn request. All right? And in case sometimes this LinkedIn has started showing as that cannot add me as a friend because of too much of traffic. Just send me your LinkedIn profile. I'll send you the request. Okay. All right. So stay connected. Whatever I mean, if you have any doubt at later point of time. Okay. So all right. And in case some idea, some concept which you think you might want to go over again, schedule a time, and I'll drop an email to other of your classmates as well that we can afford, because yours is a weekday, and weekday I can afford to slot another 1 hour or so. Okay, Mehdi? So if you have some topics which you think you could not understand, and that you should do after maybe trying to finish the class or whenever, so just drop me an email saying for 1 hour of duration, then we will schedule a session. Okay. All right all right Mehndi and Anusha, that is a better model than me going over all the topics again. All right. I'm happy, Mehdi, that you liked our sessions. So okay, so this is what Mehdi has to say. All right, I'm very happy that I was of. I mean, these sessions have been beneficial for you. Great, great. All right, stay connected. Bye bye. Bye Mehdi. Bye Anusha.